video we are going to learn about the applications of trigonometry. Application of trigonometry, as its name suggests, we are using the concept of trigonometry in our daily life problems. Okay, so here before starting the topic or explaining the questions, I would just like to tell you, as we discussed in the class, the basic concept, or we can say the terminology of the trigonometry, this type of, and in short this chapter is also known as height and distances. Okay, so we will see when we are looking at an object, if we are standing, see if the object is on our level, then obviously it will be a parallel line to our eyes and the angle will be of 0 degree. But if an object is a little raised from our eyesight or this horizontal line of sight or below our line of sight, then there will be some angle formed. You will learn how these angles formed and what are these means. See, this is the condition, first condition. When the eye of the observer is here and the object is at this point. If the eye of the observer is here, then this line is known as line of sight, and this line is horizontal level, you can say, horizontal line you can say, and the angle always formed between the line of sight and this horizontal line, wherever our eye is. Okay, so this angle, when our line of sight is going upward and the object is at raised position, this angle is known as angle of elevation. And when see the second condition, where the eye of the observer means we are at the top and the object is at down. So when the object is at the down, then obviously this horizontal line is near or just at the level of our eye. As I said, the angle always formed between this horizontal line and line of sight. So since horizontal line is this side and line of sight is going downward, so angle is formed at this point. So this angle is known as angle of depression. Okay. Because this is angle of elevation, as we know, this is angle of depression. Okay, but student, as we can see, these two lines are parallel to each other, and when these are parallel, then the AC work as a transversal. We know that the alternate angles are equal. So here, these are alternate angle, so these will be equal. If it is alpha, then also theta is equal to alpha, and the angle of depression. Okay. So now how we are using the T ratios in these kind of questions, we will see one by one. See students, there is one problem. One thing I would like to suggest you, when we are reading problem, as I said, we should first make a correct diagram because you will get a good marks for that also. And assumption is very much important. Like here it is given the angle of elevation of the top of a tower from a point on the ground. Like if the tower is there, the tower is not the slanting one. Okay, the tower is 99% is cases. It is the straight one, the 90 degree perpendicular. If this is the tower, and the angle is 30 degree. The top of the tower, the angle of elevation of the top of the tower from a point on the ground is 30 meter away from the foot. Now we have to find the height. Students, here you can see there are two. We always take that trigonometric identity in which one is known and one is unknown, so that when we calculate, we come to know the unknown value. Okay, here we can't take cos because it is based by hypotenuse, but we don't need to calculate hypotenuse. We have to calculate the perpendicular. So we will first assume here that AB equal to h meter high tower. BC is the distance from the foot of the tower. Okay, so from triangle ABC, perpendicular by base. It's 1 by root 3 is equal to h by 30. Then it comes h root 3 equal to 30. H equal to 30 by root 3. Okay. 30 root 3. It will come 30 root 3 by 3. Students, we can't leave this third here because it is not a proper manner. So 10 root 3 meter will be the height. But since it is a word problem, we will conclude the answer. Okay. And next problem is question number 5. That is, a kite is flying at a height of 60 meters above the ground. Okay. See students, since the chapter name is Application to Trigonometry and we know that it is height and distance. So obviously there is a distance from the object and height of the object is always there. So we have to recognize and draw the proper diagram. So the kite is flying at a height of 60 meters and the string attached to the kite is temporarily tied to the point of a ground. Means if this is the kite, and student, believe me, if you are able to draw the correct diagram and take the correct T ratio, I don't think your question will be wrong at all. Okay. So we have to find the, there I just, you might have seen the question. So can I draw it, the diagram properly? Here. See here. It is 60 meters. And the angle is 60. We have to find this thing. So we will say that we will erase this last time of the question so that we can have enough space for the solution. So let AB equal to 60 meters. AC equal to string that we have to calculate. So now student, we can see here easily the perpendicular is given and hypotenuse we have to find. So obviously it will be Yeah, sine. P by H. So from triangle ABC, sine 60 degree, AB by AC, sine 60 degree, root 3 by 2, AB by AC. ठीक है. Now root 3 by 2, 60 by AC, root 3 AC is equal to 120. So root 3 AC is equal to 120 by root 3. That we will make it rational. So 120 root 3 by 3, 40 root 3. So length of the string is 40 root 3. Okay. So we have to be very careful about drawing the diagram and taking T ratio. The rest everything automatically